Good morning, everyone. Am I audible?
Yes, ma'am.
Yes, ma'am.
Oh,
Good morning,
yes.
ma'am.
Let's wait for others.
Good morning, ma'am.
Good morning,
Good
ma'am.
morning, ma'am.
Good morning,
Good morning,
everyone.
ma'am.
Good morning, ma'am.
Good morning, ma'am.
I think we should start the class.
Yes, ma'am.
Okay, so we were at this numerical. This was solved, right? Solve this numerical. Find the divergence of this vector field.
Two x plus two.
Okay, solve others also. Then we'll discuss what's the answer.
2x.
Here, this is I cap, J cap, and K cap, right?
Ma'am, 2x.
2x, ma'am.
Okay. Okay. Okay, so F is given to be this vector. So Fx component is x square Fy component is 2z. Fz component is minus y. What's the formula for divergence? Del dot f is equal to
Partial
because
differentiation.
yeah, partial derivative of x component of vector with respect to x, that is curl fx by curl x, plus partial derivative of y component of vector with respect to y, plus partial derivative of z component of vector with respect to z. So this is equal to partial derivative of what is fx? X square plus del by del y. What is fy? 2z plus what is fz minus y. So derivative of x square with respect to x is 2x. Derivative of 2z with respect to y is 0 because we are differentiating with respect to y and there is no term containing y. So this is 0 plus derivative is with respect to z, but the term does not contain any z here. So this is also constant with respect to z. So derivative is 0. So the answer is 2x. Those who did not solve earlier.
बट पार्शियल डिफरेंशिएशन में तो अपन ऐसे कर लेते हैं ना कि जैसे y के रिस्पेक्ट में कर रहे हैं और y का कोई कंपोनेंट नहीं है तो उस पर्टिकुलर कंपोनेंट को कांस्टेंट मान लेते हैं अपन.
हाँ,
Yes,
ये
ma'am.
कांस्टेंट, इसीलिए तो
2z को
डेरिवेटिव
बाहर लिख
0
लेंगे
आया
ना
ना,
मैम.
इसीलिए तो डेरिवेटिव 0 आया ना, because this is constant with respect to y. I think you are confusing it with integration, I think.
No, ma'am, I have read that 2z should be written outside if it
Okay,
is.
yeah. 2z we will write it outside. Then del of 1 with respect to y. What it would be?
0.
Understand this now? Is it clear?
Yes, ma'am.
Constant is
Yes,
always
yes,
Yeah.
ma'am.
0.
Yes,
So
ma'am.
derivative of constant with respect to y is 0. Similarly here, the term does not contain any z. So minus y is constant with respect to z. So that is why the derivative is of this term is 0. So the answer is 2x. Those who did not solve it earlier, write this down. Should I move to next slide? Or anyone is
Yes, yes,
writing
ma'am.
still?
Yes,
No, ma'am.
ma'am.
Okay.
Yes, ma'am.
So next is curl of a vector. So we have done the divergence. So next is curl of a vector. Okay. So if A is vector, A is equal to x component is ax I cap plus y component is ay j cap plus z component is az k cap. And we have to find the curl of a vector. So first I'll tell you the formula for curl, how to find the curl of a vector. Then I'll describe you why we are finding the curl of a vector, like where it is physically used. Okay? First, I'll discuss only mathematically. So this is the expression for curl of a vector. Like for divergence, you denote divergence with del dot A vector. This is the divergence of vector A. Divergence of vector A. You denote the curl by del cross A. This is how you denote a curl of a vector A. And this expression, you know how to find a cross product? Determinant of these are Ax, Ay,
Yes, ma'am.
Az means I cap, J cap, K cap only. So you know how to find a curl. You write the x, y, z component of first vector over here and write the x, y, z component of second vector over here. So first you know what is del. Del operator is del partial derivative with respect to x, I cap, plus partial derivative with respect to y, j cap, plus partial derivative with respect to z, k cap. So you write these components over here with respect to x, partial derivative with respect to y, and partial derivative with respect to z. Then you write the xyz component of this vector A over here, ax, ay, az. You find the cross product and you will get the value of curl of vector A vector. Write this down on your notebooks.
Ma'am, could you explain what is curl?
Yeah, I'll explain this. I already told you. I'll first describe the mathematical expression just, and then I'll explain you what is curl. This is
Okay,
how you
ma'am.
find curl of a vector mathematically. Just write it down. I'll explain.
Okay, ma'am.
You can also write in place of ax I cap, in place of ay j cap, and in place of az k cap. It's just the notation. Done?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. Okay. So tell me what was the physical meaning of divergence? Like if a vector is going outward, you will have a positive divergence. If a vector is going inward, you will have a negative divergence. And if it flows like this, like there is no accumulation of a vector or neither there is starting point of the vector, like it, the amount which enters is same as the amount which leaves. So the divergence was zero, right? We gave an example of magnetic field vector. The divergence of magnetic field vector is zero. So in case of curl, what curl signifies, curl of a vector signifies, it signifies the rotation effect. Like if a vector is rotating like this, so the curl of vector will be non-zero. And if the curl of vector is zero, it means the vector is not rotating at all. Sorry. Yeah, so curl of a vector is concerned with the rotation of a vector field. So if a vector is rotating, its curl will be non-zero. Suppose a vector is like this. This is the current carrying wire. How its magnetic field lines will be?
Ma'am, concentric circles.
Yeah, like this. Concentric circles around the wire, like this. You can see the rotation effect here, right? Magnetic field vector B vector. This vector field is having a rotational effect, right? It's clear from the figure. In this case, curl of this B vector will be not equal to zero. That is, its curl will have some finite value. But if in some region, magnetic fields and lines are like this, it's constant and its direction is also not changing. Suppose in a region you have a uniform magnetic field which is going like this. In this case, can you see any rotational effect in the magnetic field lines?
No, ma'am.
In this case, the curl of magnetic field will come out to be zero if you calculate. So basically, curl of a vector field signifies the rotational effect in the vector field. You can imagine the ripples in a water surface when you throw some stone or pebble in it, right? Those rotational effect you can mimic. In that case, curl of the vector field is non-zero.
Ma'am, can solenoid is the example of the curl of a vector?
Yeah, so in case of solenoid also there is, yes, magnetic field lines are not straight. So like this here, magnetic field is uniform and it is not having any rotational effect. Its curl will come out to be zero. Whereas in case of rotational field, like the example I gave just, current I in a wire, straight wire, magnetic field lines are in the form of concentric circles. In this case, the curl of this B would come out to be non-zero. And if the curl of a vector field in general, I will write it down as if curl of a vector field is non-zero, that is, it has some constant finite value, that vector field is called irrotational. Sorry, if it is zero, sorry, irrotational. If curl comes out to be zero, the vector field is called irrotational, that is, it does not have any rotational effect. Is it clear? Or should I
Yes, ma'am.
repeat?
Yes.
This was a mistake. If curl is zero, then it is called rotational, irrotational. Vector field is irrotational, like in this case. Uniform magnetic field, curl was zero, so vector field is irrotational. You can write this down.
Ma'am, rotating curl means vector is not equal to rotating vector means curl is not equal to 0.
Ma'am, could you explain the second line? Uh, ma'am, you are on mute.
Oh,
मैम आपकी
okay.
आवाज नहीं आ रही
Yeah, okay, okay. So I'm saying in case of circular motion, if a particle is undergoing circular motion, it has constant speed, right? Its speed is constant,
Yes,
but its
ma'am.
velocity is variable.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Why? Because it's changing its direction, right? So when it is undergoing the
ma'am.
rotational motion, its velocity is changing, or its
Yes.
velocity is non-uniform. So rotation leads to non-uniformity in the field. Similarly, here it is saying that rotation measures the uniformity of the field. If there is rotation, it means there is non-uniformity in the field. Larger the non-uniformity, larger will be its curl. Rotation measures the uniformity means larger the rotation, larger the non-uniformity in the field, and larger will be its curl. It will lead to the non-zero curl value. Any increasing rotational effect leads to non-uniformity in the field, which leads to the larger value. Is it clear now?
Yes, ma'am.
Yes, ma'am. Ma'am, can you tell us any other meaning of irrotational?
Any other?
Any other meaning, ma'am, rotational? Irrotational other meaning?
Meaning means irrotational only means one thing, that it has no rotational effect. You are asking examples. Are you asking another example?
Yes, ma'am.
Okay. So curl in case of electric field vector, if you are considering only positive charge in some region, how will be the electric field lines?
And outward.
Yeah, it will originate from the positive charge, like this.
Yes,
Is there
ma'am.
any rotational effect here?
No, ma'am.
No, ma'am.
In this case, curl of electric field will be 0. You know, this is also one of the Maxwell equations, the earlier Maxwell equations. After that, there were some modifications in the equations, but this crude equation were one of the earlier form of Maxwell equations. Like we have written in our previous class, del dot B is equal to 0 always. Del
Yes, ma'am.
cross E is equal to 0 in some cases, like I've explained here in case of positive charge, whereas in some other cases it leads to non-zero value. That's another concept. But yeah, in case of positive charge, del cross E is equal to 0. And in this case, E vector is irrotational.
Yes, ma'am.
Ma'am,
Yes,
Ma'am, is
ma'am, इसका
curl of
real life
vector quantity?
sorry. Curl is a
Ma'am,
vector
इसका
quantity, yes.
ma'am, इसका real
So,
life
ma'am, how to
example
find its
ये
direction?
Ripple on a water surface, I told you, na? Ripples on a water surface, it has rotational effect. Yeah, who was asking curl of a vector zero quantity, curl of a vector field is a vector quantity. You can write this down also. As divergence, I told you it is a scalar quantity. Curl is a vector quantity.
Ma'am, what will be its direction?
Perpendicular to plane of the rotational, where the rotation is occurring. Similar, we are finding the cross product basically. Cross product is
Okay,
in the
ma'am.
direction, yeah, perpendicular to the plane where the two vectors are lying, right? So in this case also, where the rotation is occurring, it will be perpendicular to that plane. Suppose this magnetic field vector is rotating in xy plane. So its curl will lie in along z axis.
मैम इसकी भी कोई यूनिट नहीं होती है?
Actually, like in case of divergence, I was saying to you, so you're finding the cross product, right? So there, in case of del operator, there are del by del x, del by del y, and del by del z, right? So it is the unit of inverse length. So whichever vector you are finding the curl of, it depends upon that. You don't write its units. Like I told you in case of divergence, you don't write the units of divergence. Whenever you find a divergence of a vector in your earlier numericals, I gave you 2 numericals. You don't write the units along with the value of divergence. You just write the expression. In case of mathematics, when you are finding the derivative of some function, suppose, do you write the units along with that? No, na?
No, ma'am. No, ma'am.
Suppose, yeah, you are given some function fxy. Any statement is
Yes,
there.
ma'am.
You find the derivative of this function. You don't write the units along with that. Similarly, in case of this, basically these are the different forms of derivatives. See, in case of divergence, what you are doing is you are partially derivating and partially differentiating and then adding those terms, right? So this is one form of derivative now. Divergence. Similarly, in case of curl also, you're basically partially differentiating. So these are the 2 forms, and third one is gradient. I'll come to you, come to the gradient in next slides after I complete the curl. So you don't
Mathematical
write the
example
units.
of curl.
इसका mathematical example.
मैम कर्ल का
Mathematical example, mathematical functions.
यस मैम जैसे ये
Okay, I'll give you
मैट्रिक्स में
I'll
से
give you
सॉल्व कर
numerical. Sorry,
यस मैम
sorry.
वही मैम न्यूमेरिकल के लिए बोल रहा था
Yeah.
Ma'am,
Yes.
Ma'am, could you please explain again how we find direction of curl?
Okay, so expression of curl is mathematical expression is basically find the cross product.
Yes, ma'am.
Yeah, so cross product, how you find the direction of cross product? Suppose you are finding the cross product of vector A and B. It's perpendicular to the plane containing both A vector and B vector. So in
Yes,
case
ma'am.
of curl, it's perpendicular to the plane where the rotation is occurring. So in this case, as you can see, if B vector is rotating in this plane and this plane is XY plane, this one, this plane, it is XY plane. So it will be perpendicular to the plane of rotation. So curl will lie along this direction in this case.
Okay,
Basically,
ma'am.
curl is a cross product, so its direction will be same as that of cross product.
Okay, ma'am.
Okay, ma'am.
Okay, so if everyone has written this down, can I move to next slide?
Yes, ma'am.
Yes, ma'am.
You have also written this now. Curl of a vector is a vector
Yes, ma'am.
quantity. Okay, so solve this numerical.
And x minus 1.
No.
Ma'am, curl.
Have you used correct formula? These are the unit vectors. I cap, J cap, K cap.
Ma'am,
Yes.
ma'am, what were the capital AX, AY, and AZ in the formula?
These are the, I told you, you can replace those with I cap, J cap, K cap.
No, ma'am, capital AX, capital AY.
Okay, these are the components of vector whose curl you are finding.
Okay, ma'am.
Okay, so if A vector is this, AX I cap, then you write that formula.
जीरो y minus जीरो j plus y minus 3y square k.
Correct. Others also solve this.
3y square minus y k cap.
Sorry,
3y square minus y k cap.
there is some problem with the sign. The answer is correct. The problem is with signing. Positive and negative signs. Check the calculations.
Yes, ma'am.
y minus 3y square k cap.
Correct.
Ma'am, minus 2y k cap.
No.
Ma'am, y minus 3y square minus k.
Okay, we'll solve it here also. So you have to find curl of F vector. This is equal to I cap, j cap, k cap, del by del x, del by del y, del by del z. What are the components? Fx is y cube, Fy is xy, Fz is minus z. So this is equal to I cap into del by del y of minus z minus del by del z of xy. Minus j cap del by del x of minus z minus del by del z of y cube. Plus k cap del by del x of xy minus del by del y of y cube. Derivative of z with respect to y is
0.
0.
0. And derivative of xy with
0.
respect to z is again 0
0.
minus j cap. Derivative of z with respect to x is 0. Similarly,
0.
y cube's derivative is with respect to x, z is 0. So what we are left with only k term, k cap. This its derivative is y is constant, x
Y
derivative
k
with respect to x is 1 minus 3y square. So this is the answer. Y minus 3y square k cap. In this case, curl of this vector field is in the direction of z-axis, along the z-axis. Those who had not solved earlier, write this down.
मैम फिजिक्स में पहले ऑप्टिक्स पढ़ाई होगा या मॉडर्न फिजिक्स?
वेव ऑप्टिक्स, ओके। सबसे पहले फर्स्ट यूनिट जो है लोगों का वो रिलेटिविटी है, relativistic mechanics. I'll also discuss this unit-wise syllabus with you. someday, in a day or two.
Okay, ma'am.
Ma'am, your voice is not clear.
Is it now clear?
Yes, ma'am.
Yes, ma'am.
So I'm saying I'll discuss the unit-wise syllabus and exam pattern and all other things with you someday in a day or two.
Okay, ma'am.
Okay, ma'am.
So what the two different forms of derivatives we have done? One is divergence, del dot A vector, divergence of a vector field. And then we covered curl of a vector field, del cross A vector. Now we will do these two were for vector field. There is also one form of derivative for scalar field. If A is a scalar, then the derivative is called gradient of A. That is our next topic. Everyone has written this down, this numerical.
Yes,
Should I
ma'am.
move to next slide?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
So next topic is gradient of a scalar. I told you there was divergence of vector field del dot A. And the outcome, what is divergence? Is divergence a scalar or vector?
Scalar quantity.
And scalar.
Scalar quantity. So divergence of a vector quantity is a scalar quantity. Then we did curl del cross A vector. Here also in the we gave as vector, input as a vector, but the outcome, the curl, is this a scalar or vector quantity?
Vector.
It is a vector quantity.
Vector.
I'm discussing the third one. Actually, it was the first one, but I'm coming to it in the last place. Gradient of a scalar. So if A is a scalar quantity, we take its gradient and we denote it like this, del A. Gradient of a scalar, it will be a vector quantity. So first I'll discuss the mathematical expression. This is the mathematical expression, gradient phi. You can replace the function A with the function phi. Phi is a scalar function, like phi is a function of x, y, z. I'll give you some examples also. It can be of any form. Like phi x, y, z can be of the form, suppose x cube, y, z, something like this. Okay, so phi can be of this form. It is a function of x, y, z coordinates. So if phi is a scalar function, so gradient of phi, we denote it like this, del phi. This is equal to partial derivative, this del operator you write. Then you operate this operator on this function phi. So del by del x phi I cap, del by del y phi j cap. Basically, what you are doing is you're differentiating function phi with respect to x first, and then with respect to y first, and then with respect to z. And these are the x, y, z components of this gradient. I cap, j cap, and k cap. So this is gradient of phi. So what is the x component of grade phi or gradient of phi?
And del phi by del x.
Yes. X component of gradient phi is del by del x. Similarly, what is the y component? Of
Del phi
gradient of phi.
by del y.
Yes, y component is
Del Y by del Z.
del phi by del phi. And the z component of gradient is
Del phi by del z.
del phi by del z.
z.
It's a vector quantity. You can see it has x, y, z components, and it is a vector quantity. First, you write this mathematical statement. Well, then we'll discuss more about gradient.
Okay, ma'am.
Okay.
Excuse me, ma'am.
Sorry.
Excuse me, ma'am. Ma'am, इससे velocity gradient जो हमने पढ़ा था 12th में वो इससे connected है इस topic से.
वेलोसिटी ग्रेडियंट कनेक्टेड नहीं है, ठीक है. ग्रेडियंट मींस देयर इज अ चेंज, सो दैट वाज फॉर चेंज. दिस इज समथिंग एल्स. Okay, because velocity is a vector quantity and gradient is defined for a scalar quantity. Understand the difference? The velocity vector, this is a vector quantity, but we are defining here the gradient of a scalar quantity. So you are asking about velocity gradient. That gradient was not this physics one. It is an English word, gradient. It means change. The gradient you are talking about now, that means change in the velocity. Yes.
Okay, ma'am.
मैं पोटेंशियल ग्रेडियंट इसी से रिलेटेड है
किससे? कौन सा?
पोटेंशियल ग्रेडियंट.
Yes. Yes, absolutely.
ओके मैम.
Actually, it is the best example of gradient. I'll come to this later. Now you write this down, the mathematical expression. I'll give you an example where this gradient is mostly used in physics.
Ma'am, last one is not clear. Del A vector.
Del A vector. I just told you that gradient of a scalar is a vector quantity. It's not that important. It's written over here also that this defines a vector field. This means that gradient of a scalar is a vector quantity.
Okay, ma'am.
Is it done? Have you written this down?
Yes,
Yes,
ma'am.
Ma'am, 1 minute.
Okay. So
Yes,
now
ma'am.
tell me one thing. You have written here x component is of gradient is this, y component of gradient is this one, and z component is this. So if I ask you that the projection of gradient in some particular direction, what does it mean? Projection.
Component
Of-
in that.
Yes. So if I ask you projection, it means the component of gradient in a particular direction. So it means x component is this thing. What is this signifying? Change in function with respect to x. So x component of gradient means rate of change of the function with respect to x. And y component is signifying rate of change of function in the y direction. So basically, in which direction the component is there, you are just partially differentiating the function with respect to that component. Are you getting my point?
Yes, ma'am.
That if you have to find the x component, what you are doing is you are just differentiating the function with respect to that direction. So basically, component of a gradient in any direction, you write this down. Component of a gradient, component of a gradient of a function in any direction component of gradient, I write it in short form, gradient of a function in any direction is defined as rate of change of change of function in that direction. That direction. Is it clear? He is saying that component of gradient of a function in any direction. Like you take the example of this z direction. So the component of gradient of phi in z direction, it is defined as the rate of change of function in that direction. Is this clear? What I've written here?
Yes, ma'am.
Yeah, so you write this
Yes, ma'am.
down. This is basically the physical significance of gradient. I'll further elaborate this. You just write this. I'll also give you an example. Okay, I'll write it here. Example of gradient.
मैम एक बार और समझा सकती हैं?
Okay, so gradient, the mathematical definition, you have written this down. What you're doing is del phi by del x I cap. That is in x direction, you're differentiating the function with respect to that direction. Here, like, plus del phi by del y j cap. So its y component is, you are just differentiating the function with respect to y plus del phi by del z k cap. So this is a vector quantity. This gradient is a vector quantity. What is its x component? Del phi by del x. What is its y component? Del phi by del y. And its z component is del phi by del z. So if you find the component of gradient of any function in some direction, what is its expression? How it is defined? It is the rate of change of function in that direction. That is, if we are finding the x component, we are differentiating the function with respect to x. Similarly, if we are finding the z component, we are differentiating the function with respect to z direction. So whichever component or in which direction we are finding the gradient, it is the rate of change of function in that direction. Is it clear?
Yes, ma'am.
Excuse
me, ma'am.
Example is, can you tell me what is the relation between electric field and potential energy, or simply potential, electrostatic potential? Yes,
Equals to
issue.
minus dv by dr.
Yes,
E equals
issue.
to minus dv by dr.
E is equal to
Minus dv by
minus,
dr.
yes,
dv
by dr.
by dr.
So this r is the position vector, right? How do you write
Yes,
r
ma'am.
vector? X I cap plus
Yj
y j cap plus
plus
z
zk
k
cap.
cap, right? So it is three
Yes, ma'am.
dimensional. It is three-dimensional, right?
Yes,
You
ma'am.
can write this as E is equal to minus gradient of V. In Cartesian coordinates, how it will, we will continue this, okay? This discussion, we will continue tomorrow class. You write this now. I'll continue from the example.
एक्सक्यूज मी मैम.
Yes.
मैम अगर कोई चीज टाइम के संग चेंज हो रही है तो उसको हम इसमें इंक्लूड करेंगे क्या?
नहीं, gradient is only the differentiating with respect to the space position coordinates. There is no
Okay, ma'am.
temporal component, only spatial component. So gradient is the spatial derivative. Okay,
Okay, ma'am.
Okay, ma'am.
so we'll continue from here. Can I stop sharing? Has anyone left who has not written this down?
Written, ma'am.
Or should I
Done,
give
ma'am.
a minute or so? It's done now?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
Yes, ma'am.
So I'll take your attendance. Yes, Aditi? Aditi, you want to ask anything? If you have questions, you can ask. Okay, so I'm leaving the class. I'm ending the meeting. Thank you.
Excuse me, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.